Hello, my name is Zachary Hedges. This is my lab 4 submission on oscillations. The purpose of this lab was to track the oscillation of a spring with a mass attached to it while it was swinging. Tracking the motion allowed us to observe the changes in energy in the system. The system consisted of a spring, mass, and the earth. The key physics principles in this lab were Newton's second law, the energy principle, the momentum principle, forces, and potential and kinetic energy. I found that I was able to model the behavior of the ball using both fairly well, that the total change in energy in the system was zero. Newton's second law states that mass times acceleration is equal to force. We use this calculated force when updating our position and velocity in our computational model. The force is calculated by adding the gravitational force and the spring force, where the gravitational force is found by multiplying mass by the gravitational constant, which is equal to 9.8. Spring force is calculated by multiplying the spring coefficient times the change in length of the spring. Spring potential energy is given by 1/2 kx squared, where k is the spring coefficient and x is the distance the spring stretches. Gravitational potential energy is given by mass times the gravitational constant times height. Kinetic energy is given by 1/2 mass times velocity squared. The energy principle states that the change in energy of the system is equal to work done by the surroundings. The period of oscillation of a spring is given by 2 pi times the square root of mass over the spring constant. To obtain the data for this lab, I used Tracker and the provided video to track the motion of the spring as it completed several oscillations. The initial conditions were given by my tracker data and provided in the video. The ball's mass was 0.42 kilograms. From my tracker data, I found the initial position of the ball to the spring mass to be this. The spring constant and relaxed length of the spring were both provided by the video, and I used these to calculate necessary information for calculating energy changes. I applied the formulas previously discussed to calculate the energies using my other constants. In the loop, gravity and spring forces are updated to recalculate net force, which is then used to recalculate the ball's velocity and position. As the position updates, the length of the spring changes, which updates the spring potential energy. And then using these recalculated values, I do the same thing as before to calculate the changes in energy. My computational model provided this graph where the green line is the change in energy of spring potential energy. The red line is change in gravitational energy. The blue line is the change in kinetic energy, and the orange line is the change in total energy. The total change in energy was 0. The change in potential spring energy increased as change in gravitational potential energy increased. This graph shows the exposition versus time for both the computational model and my experiment, and they both have pretty similar results. And that is the same for the y position versus time graph. Some sources of error in this experiment are not clicking the same point in tracker in each frame. This results in minor discrepancies between the computational data and the real data. I also did not account for other external forces such as air resistance that could have affected the motion of the spring in the computational model. We also made the assumption that no energy is lost to the surroundings. So since the sum of the change in kinetic energy, spring potential energy, and gravitational potential energy is 0 with the whole experiment, the change in total energy is 0, so the energy principle is satisfied. Then using the exposition data and tracker, I found the distance between two crests to find the period of oscillation to be about 1.619 seconds. I did the same for the y position graph to get a period of oscillation, 1.524 seconds. There is a greater period of oscillation in the x direction, because the spring force is the only force acting in this direction, whereas the y direction has spring and gravitational force. And that concludes my presentation.